Good afternoon and welcome to the Sustainable Materials Management Webinar Series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen and I'm the Program Manager for the Center and will serve as your moderator today. We would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series, and Lisa Ruggiero and Savannah Batowski of the National Recycling Coalition for assisting the RMC with webinar promotion and technical support. Today's webinar topic is battery recycling. Our presenter today is John Kincaide, who I will introduce in a moment. Following the presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you're experiencing technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And now I'd like to introduce our presenter. John Kincaide is president of E-Waste Brokerage, Inc., which is doing business as WeRecycleBatteries.com. This operation is based in Alden, New York. John is also an authorized New Life glass broker for business development to source CRT glass to the New Life Glass New York plant, located in Dunkirk. Previous to his current business affiliations, John was channel manager for Callstream Communications Limited in Oakville, Ontario. He was sales manager for Zenatech Toronto, Ontario, and president of Schedule Solutions Inc. of Toronto also. And now I'm going to turn the program over to John.
Yeah, thanks very much, Wayne. Just a little bit of background about my company. I started the business back in 2010 after finding an illegally dumped battery in Cape Cod. And what spurred the industry as development of e-waste brokerage is really what we do is we focus on focused materials. That's our sort of philosophy. So focused materials in the e-waste industry are things like batteries, CRT glass, mercury-laden fluorescent tubes, and other materials. We specialize in the first two, batteries and also on CRT. As I said, I started this business because of an illegally dumped battery. The business started in Toronto and grew quite fast. And we have shipped literally millions of pounds of batteries in the last 6 years. In 2013, I moved to Buffalo, New York area in Alden, New York, and started up and formulated E-Waste Brokerage Inc. in March of 2013. As mentioned, Wayne had mentioned, my company also, because of the CRT aspect, we're the only authorized New Life glass broker to provide business development services to bring glass to the two facilities now, one in Dunkirk, New York, as well as in Bristol, Virginia. Currently, the Dunkirk, New York facility has the only electrochemical furnace that can take the lead out of glass, out of CRT glass. Typically, a 15-inch to 17-inch TV CRT tube would have about 2 pounds of lead in it. So this is a very unique opportunity for the United States and the world, for that matter, to be able to extract CRT lead. Moreover, I will point out that the lead that's coming from these CRTs are going into battery manufacturing, which means we're injecting it into a whole new life cycle, which I'll discuss in the presentation. So the other thing that we also have developed over the last year and a half is we have developed a concept of reusing some batteries, industrial batteries, for solar energy storage. So this is called second life battery usage in the industry. We have developed a way to identify, out of the millions of pounds of batteries we do get, some batteries that are still have some life in them, and be able to recycle them and use them for reuse. So, next slide. Okay. So we're going to discuss overall the program today is about the 3 R's of recycling: reduce, reuse, recycling. The U.S. market demand and supply, the different types of batteries, the types that are categorized by non-rechargeable and rechargeable, the regulatory framework, including hazmat regulations, as well as some of the other restrictions on movement of materials, and look at who pays for recycling and how it's paid. And lastly, we're going to look at the future, because we look like we're kind of a major new opportunities because of a large amount of battery waste forthcoming in the industry. So first of all, really, we cover the recycling aspect. The major reason why we want to recycle batteries is because of the inherent materials inside them. There's nickel, there's lead, there's rare earth, there are even some more intricate metal products that are very important, and also lithium and lithium-ion technologies engender the lithium salts that are necessary to power our future and renewable future as well. In case of rare earths, there are certain types like cerium and neodymium and other ones. We'll get into that in more further detail. And as for reuse, I mentioned this second life before. It's basically be able to reuse a battery in an application for energy storage. Reduce is kind of an unusual thing. You don't want to. How can you actually not use a battery or in an application? So where it's the only way you can really sort of look at this problem is how to not use it as much. Make sure it doesn't become useless. So use it less to make it useless, to prevent it from becoming useless from abuse. So the fact here is that typical applications that in the renewable energy industry is looking at lithium-ion technology. Typically, lithium-ion batteries are rated by a number of full deep cycles that they're able to expend. So that when a manufacturer may say there's 1,000 particular full life cycles in a particular battery, some are much more. But instead of actually trying to drain that, if you use that for your home, 1,000 cycles will last only 3 years, roughly. So the fact is that they will bulk up the size of the batteries and then only use 30% of that usage, and therefore you can run for 12 years. Those are the kinds of applications. The trade-off is that you have more batteries at the end of life, but you are able to extend that life over a long time and amortize your costs. Okay. Now we're going to talk a little bit about the marketplace. These numbers down on the left-hand side here are actually in millions of dollars. We're actually think them as billions. It starts at $5 billion and go up to $30 billion. These trends came from Fredonia market analysis. The things that you have to really sort of think about here is the overall demand. There's two types of batteries, and I'm going to use the terms primary and secondary. They're kind of interchangeable with, I think of primary as being non-rechargeable and secondary batteries as being rechargeable. In other words, you can use it twice or more. The thing you find here is on the lower hand corner, the brown sort of primary line, and you can barely ever see the demand curve just laid over top of it. Is you're going to see the typical alkaline batteries and lithium disposal, non-recyclable batteries. They're just going to be growing at a very small pace. But what you'll see is in the middle of the chart here, the dark purple and the light blue. The dark purple is the demand curve for secondary products, and the supply chain able to supply that is the same. It's a hockey stick kind of approach. What's going to happen is this reason why the 2014 and on pricing is just exploding in terms of market capacity is because of the cost per unit of measure they use in the solar energy storage industry is kilowatt hours. So a battery that was a lithium-ion battery that was manufactured in the late 2000s would be maybe $300+ per kilowatt hour, and now it's getting, as of 2016, is now about $150 to $200 kilowatt hour, and eventually about 2019 to 2022, the price is estimated to be about $100 per kilowatt hour. Why is that important? Well, $100 per kilowatt hour is roughly where the cost crossover is for competitiveness against fossil fuel usage. So therefore, you can use a lithium-ion battery or similar kind of technology to actually support large installations of battery capacity One of the major things that's going to happen in the renewable energy industry is that, well, the grid that we all live off and depend upon today, it was never designed to actually handle enormous amounts of stuff on its fringe or in the middle of its grid. And what happens, the grid has to be carefully balanced from its sources. So you've got a battery plant like we have in Niagara Falls, New York, which generates 2.7 gigawatts of power. That has to be distributed over an enormous network that covers most of the Northeast United States and parts of Canada and Ontario and Quebec. By putting the battery technology in the middle with the solar support or wind, it tends to it levels out that support. In other words, because the sun only shines during the day and the wind can only blow, sometimes supplements it at night. But if you have the highest demand at nighttime and the sun's no longer around, you have to actually put the battery technology in there to actually support that continuous flow of electrons into the system. So that really the takeaway. Also, the other factor is going to be the major advance in computer, in electric vehicles such as Tesla and others. Tesla is forecasting starting 2020 roughly to produce 500,000 cars per year. Each one of those has 85 kilowatt hours capacity potentially. To give you a sense of what that means in context, you could drive that car for 250 miles on 85 kilowatt hours, or you could power your house for a day for 30 kilowatt hours. So you can imagine the demand that's going to be needed for batteries to be able to support that, and the lithium that needs to be put into those systems. So there's going to be a lot of battery waste sometime down the line, and most of the lithium-ion technology is a 7 to 10 year proposition. As for the regulatory environment, from a day-to-day aspects, there are really things that are touchstones. One is the hazmat transportation regulations. This is an international law, and U.S. has some variations of it. There's tweaks to the hazmat regulations in the United States to allow maybe a little easier movements of some of the battery waste. Essentially, not to go into a hazmat class, which is quite complicated, hazardous materials are classified in 9 different classes of products, covering thousands and thousands of different types of chemistries or chemicals. Some of them are very, very nasty or very dangerous, and some of them are not so nasty, but could be somewhat hazardous to health in the environment. So the worst ones are explosives and nuclear, explosives at class 1, and class 8 are like, and down to class 8, which is caustic. You may see a sign of a truck going down the road with a triangle, the black triangle with a hand being burned by a test tube of acid. That's a class 8, and class 9 is also the lowest of them all. Generally speaking, batteries that are actually hazardous will fall into the class 8 and class 9 classifications. As I mentioned, there are certain U.S. domestic DOT exemptions on movement of materials. Won't go into them, they're kind of complex, but essentially there are ways to move stuff carefully under some very oblique means of exemptions to actually allow them to be properly transported within the United States. For example, it is possible to actually ship a full truckload of lead acid batteries, which are wet full, and you may have about 400 gallons or 600 gallons of acid in the back of the truck. But in the United States, if it's a dedicated shipment, you do not have to placard the truck or show that it's actually hazmat. In Canada, it would have to be. Everywhere else, it would have to be. Also, the fact is that we all have, there are a certain limited number of resources to actually recycle batteries. Some places have the need to have the material imported into the United States, or some places actually need to export it. You just can't pack up a trailer and or a container and ship it overseas. You actually have to get permission to ship it, and that's under the UN Basel International Treaty. So it involves is that, and if you wanted to ship, somebody wanted to ship something to the United States, they would actually have to get permission from their equivalent to the EPA, and then that organization would have to notify all the countries, and including the US, EPA, of its intent to ship the material and who's going to process it. This stuff can take months, because what happens is that every single country that touches it, or even the ship transits a port or go through the territorial waters of that country, have to be notified and give approval. Things that are sort of unique to the United States in terms of waste, battery waste, is battery waste is classified as universal waste. It's not considered a hazardous waste. Now, what that does is it allows people to manage the battery waste in a not such stringent requirements for transportation and storage. There are requirements to make sure, and sometimes depends on the volume or the amount of weight or material that you're processing a year, you may have to register an EPA number and have certain other restrictions, but it doesn't have to be like a full-blown hazmat hazardous waste depot. Speculative accumulation is an EPA regulation in the United States. And basically what happens is that there are some batteries, there are lots of them, that don't have any value whatsoever. They actually cost quite a lot. In other words, like a lithium primary battery may cost many dollars to recycle per pound, depending on the chemistry. So you just can't say, gee, I've got a whole bunch of this stuff and I'm going to put it in a warehouse and forget about it and it's going to cost me a lot less. You can't do that. It's illegal. You actually have to turn over your battery waste and get it recycled 75% within 1 year. And also the other thing too about Superfund liability is that, especially my company, we're a brokerage firm. We don't actually process anything here, but we actually work with the best processors in the marketplace. And so the Superfund liability is if you ship anything with us, we actually are the generator of record. So we are the first line of defense and liability. So we are onus on us to make sure that we actually make sure that our processes are within the realm of the law and liability. So the fact is that if you want to ship lead acid batteries or some other battery product yourself, there has been unfortunately a history of in the lead acid battery industry of some companies that have gone out of business and had Superfund liabilities. And the Superfund liability can actually extend past your own estate. There was a case in point in Texas a few years ago where a battery broker had shipped product to a defunct secondary lead smelter in Texas, and he died, left the estate to his wife, but they went after, the EPA thought they should go after the wife, his estate, for help pay for that. I don't know what the outcome of that particular case, but there was a newspaper article about it. Now the next thing is, what kind of volume of waste are we seeing? Well, we're seeing about 2.5 million tons of lead acid as of 2012. And that means car batteries, forklift batteries, other kinds of batteries that have lead acid. Lead is a wonderful product in that it actually has a 100% recyclable rate. We have actually motivated people very well to actually recycle their product. It's actually the most recycled product on the planet. About 95 to 98% of all batteries are lead acid batteries are recycled. So it's in theory that your grandfather's car battery has probably got an atom or two of yours in your current battery. The market here, the other marketplace for rechargeables, some of these are actually have some value and some don't. There's an organization called Call to Recycle, which is a association of battery manufacturers that set up a branding program to actually identify batteries that need to be recycled, and they set up a distribution channel, many collection sites at Home Depots and other retail locations for rechargeable batteries to be collected. They collected 10 million pounds just in 1 year in 2012. Personally, I think that these are just scratching the top of the surface. There's a lot more battery waste out there that's not probably getting into the stream. So I wanted to talk about different types of batteries. I mentioned that rechargeable batteries, as I mentioned earlier, are secondary batteries are sometimes used. They basically are able to use more than once. So you've got lead acid, lithium-ion, nickel-cadmium, which comes in a dry or wet cell, and then the nickel metal hydrides. I mentioned this before, the 98% recycling rate. There is a difference in the wet versus non-spillable product. That is more of a factor in the how in the United States and how the non-spiller product can be exempt from hazmat regulations, transportation regulations. You can see on the bottom right here these big huge forklift battery. It probably has several gallons of acid. What happens with lead acid batteries is that they actually break them up at the secondary lead smelters. There's no longer a primary lead smelter left in the United States, so all the lead that's being produced in the United States right now is coming from existing lead acid batteries. So what happens when you deliver a battery like this to the smelter, they break off the steel case or the case, they smash it up in a battery breaker. The acids are actually either neutralized and actually goes right into the special sewers. It is absolutely clean, or they actually recover the sulfate and create other commercial products from it. The lead plates are then broken up and resmelted back into the furnace through furnace process and purification, and it's sent back out as product for new batteries. Next one. Now, lithium-ion. Lithium-ion has 5 sort of major different recipes of batteries, chemistries. Now, a battery consists of basically a positive negative plate and some type of electrolyte in the middle, which is a soup of chemicals that are used to help transmit the electrons between the two terminals. When I say recipes, I'm referring to the electrolyte. And really, the lithium-ion technology is taken off because you get a tremendous amount of energy in a much smaller space. As you can see in this picture in the upper right, this is a battery that's about the size of a small motorcycle battery, but it's not a lead acid battery. It's actually a lithium-ion battery, and it's probably about 4 or 5 inches, as you can see in the ruler. That chemistry, so there's really, as I said, there's 5 chemistries. One of those chemistries has cobalt on it, and if it's got cobalt in it, it actually is a positive value product, depending on how much cobalt is in it. So if you've got 20% cobalt, you've got a very good chance that your lithium-ion battery technology will have some residual value and be able to get paid for it. Unfortunately, the other 4 don't. There may be some a little bit on one other, but not enough really to pay for the recycling. So it can range into negative value quite quickly. And this is a major problem. The fact is that in the future, we're depending a lot on our future energy future on lithium-ion technology. We'll all face the problem. And I mentioned this again at the end of the presentation, what we're going to do with that problem. I mentioned this is that the cobalt is found kind of near other nickel deposits. There's a famous place outside Northern Ontario called Cobalt, Ontario, which was where a major mine once was in the 50s and the 60s. Also, the problem is that the sourcing of this material has to be fair trade. And at this point, I'm going to try to minimize my slide. And Wayne, help me if I don't do this right. Can you see this this PDF file?
Yep, that's up.
Okay, this article here shows how in Congo, which is in Central Africa, where Congo's got a blessing of a large natural resource of cobalt. It's literally laying in the ground. It's an unusual geological deposit. But what's happening here is that you can see this poor man here is actually he dug this hole by hand and into the ground, down into the tunnel, and he'll spend a day and night in there banging away at the cobalt ore with his bare hands and just hand tools to extract this material. And what this article from the Washington Post was, it discusses how he had to make a choice one day either to pay for salt or flour for his wife. It is really an unfair situation where fair trade isn't happening, and some of these people are not actually being valued. Second. So the aspect of this is that we have to make sure our supply chains are right and valuable. And I can share this article and put a link in my website for this in the future. Okay, we'll go back here. And slideshow. One thing about this particular battery here, up in the right-hand corner, lithium-ion battery, is that these are quite a bit of danger to our friends in the lead-acid industry. There was a case in point where I saw a video last month at a trade show. We're talking about high-energy battery recycling, and they showed a scene where you had these batteries that were on a conveyor belt going up to a battery breaker, a lead-acid battery breaker, and suddenly there was this enormous explosion. It was like a grenade going off because the battery breaker had hit one of these lithium-ion batteries that looked like a car battery. It wasn't done on purpose. It wasn't like a terrorist effect, but it was just because somebody had put it in by accident. So the fact is that when sorting, this points out the fact of sorting batteries is so important to make sure nothing goes wrong. You look at this particular battery, it looks like a car battery. If you look at the one down the lower right, you look very carefully, you'll look at what looks like a AA battery, like an alkaline battery. But in fact, it's one of those Energizer lithium-ion batteries that are using to extend battery life for, say, cameras and other kinds of things that use a lot of use. If that went into a battery breaker at an alkaline battery plant, it would actually blow up. It would make more like a small bang, not like a grenade like the one on the top. We talk about the lithium sources. I mean, there's commercial sources where the lithium salts are extracted. They come from in Chile. One of the major suppliers. It actually is not mined like the Congolese miner. It actually comes in like an underground water salt baths, reservoirs underneath the ground. And what they do there is they actually pump it all up and then expose it to the desert sun and actually dry out the salts and then separate the lithium carbonate primary lithium ores out of it and purify it. Just to give you an idea of how important lithium is, a Tesla, I read an article that a Tesla will actually needs about 10 pounds of lithium, raw lithium product into a lithium-ion battery pack to actually run it for 250 miles in one charge. So we're going to need a lot of lithium to make sure the system works. Nickel-based batteries are another, sometimes are secondary use batteries or rechargeable batteries. I mentioned the rare earth before with the nickel metal hydrides. Nickel CADs come in two different types. One is dry and wet. The wet is definitely a class 8 hazmat shipment. It's instead of using acid, they're using alkali as the electrolyte. And the dry, as you see in the picture on the lower, are like big cells. They kind of look like big, oversized D cells at times. Sometimes the manufacturers, such as Sanyo in this case, actually chose a very bright yellow color that helps her maybe identify it. There's no standards for identification and sorting. It's whatever the manufacturer feels it's necessary. So sometimes they NiCad cells can show up well in the stream. Sometimes they look very nondescript. This phrase here, greater than 9, insulating is fine, is a slogan I use to help my customers and suppliers to understand that the regulations in the United States and probably elsewhere is that you've got to insulate NiCad and nickel metal hydride batteries, the terminals themselves, with tape. It's DOT fine. If you ship stuff that's not DOT compliant intentionally in the United States and you don't have the proper documentation and training, the fines can start at $75,000 and can also add some jail time. So it's very, very important to make sure that you know your product, be able to sort it properly, be able to understand the implications of its transportation. Alkaline batteries, we're also familiar with them. They are a negative value product, and unfortunately there's an enormous amount of them. There's about like 1 billion batteries per year that's actually manufactured in the United States a year. The general lifespan of an alkaline battery is about two years, maybe 3 if you're very lucky. But we all switch out at twice a year. Our alarm, even our fire alarms in our houses. I mean that takes several batteries. but generally about 10 AA batteries is equal to about a pound of waste. So you can imagine a billion batteries, where we've got a lot of battery waste, a lot of weight. The one thing that can be done with alkaline batteries, if it's properly recycled, is actually put it into a recycling line and crushed. And inside alkaline batteries, there's potassium hydroxide, there's some manganese, there's other flavors of chemicals as well. There's a couple of companies here in North America, one in Canada and one in the United States, that actually allows you to, what they do is they shred the stuff, be able to extract the chemicals, sort the difference and do some pre-processing on it, and they become precursor chemicals for fertilizer. Some of that fertilizer goes to the corn ethanol industry in the Midwest United States. So in effect, your 10% ethanol content could have been literally, quote unquote, powered by an alkaline battery that was recycled. Unfortunately, there's the issue here is that people throw the stuff out, and the reason into the trash, and that's really a problem. We're also losing a great resource, as you can see in the example with the ethanol. But also the fact is that the Congress about 15 some odd years ago passed a law that said no mercury is allowed to be in alkaline batteries. They used to salt the alkaline batteries with mercury to provide a better power storage capacity. Unfortunately, that meant that people could just dispose of, I think they could dispose them in household waste. That's the case. But there's a new problem I've seen recently in the marketplace. I recently purchased a voltmeter. It had a 9-volt alkaline battery, but it had the PB symbol on it, and I went, that's very unusual. More and more I'm seeing more and more of this product. The big problem with this is that those batteries can't be recycled by anybody. That doesn't have a special, it can handle both the alkaline and the lead. So the secondary lead smelters won't touch them, nor will the alkaline process, because the lead will poison the alkaline process, and and vice versa. So there's another problem to be solved. Where's the money? Well, here are the batteries that actually make money, or could potentially provide you some source of income. Lead acids, as I mentioned, is a very large market. And how that works is that when you buy a lead acid battery, particularly car batteries, there's usually a fee attached to it. In other words, you buy your $100 car battery, there's probably a $10, what we call a core charge for the lead. And so that motivates you to, when you bring back your old battery, to get the $10 back. And that is really what's powering the whole market. Same thing with some of the larger lead acid industrial batteries too. There's a fee associated with the sale, and when years later some of those big lead acid batteries can last 10 to 15 years, they do get the money back for that core charge. But when you're in that market, it's not like I'm worried about my $10. They're worried about supporting multi-million-dollar data centers and other kinds of things. It's just peanuts. The nickel metal hydrides are valuable. There's a fluctuating market, but the fact is that they are able to. The value in it is the the rare earths. It's not the nickel. Nickel has taken a real punishment of late, and in the last 2 years in the commodities market. The lithium-ion, there's some reuse of the market. There's like laptop batteries, cell phone batteries. There's one of our processors does do this. And what they do is they test them, make sure that they are meeting the R2 standards for export, and be able to provide it at a lower cost to go into other products, maybe not as critical, maybe toys and other things. And then there's also lithium-ion cobalt recovery, which, as I mentioned earlier, that's the value in this. And if it's a lithium-ion cobalt recipe, it can be recovered. But the difference between the two pricing of lithium reuse and cobalt, the cobalt is much less. Things you must pay, which we've already touched on, are alkaline, lithium non-rechargeable batteries, and also nickel cads. The dry cells and the wet cells are, unfortunately, nickel cad at one time was value, had some value, but it's so depressed now. The fact is that the cadmium is the culprit in this one. The cadmium is very toxic. It's actually probably more toxic, or more toxic than lead. And the fact is that the market for nickel cad is not nearly as vibrant as it was. So the processors are actually capturing the nickel, and they are not making as much money on the nickel where that's usually sold into the steel industry for stainless steel. But the cadmium is not going, is not much demand anymore for new batteries. So that is a problem. So that's the reason why to get rid of the cadmium, you actually have to spend money to get rid of it. Then we can talk about really here is the producer responsibility aspects of how to recycle, who's going to recycle, who's going to pay for all this. Unfortunately, if it doesn't have an inherent value, intrinsic value, where the market will decide, the extended producer, the only way to do it is actually have a federal, or I mean, not federal, but some type of payment program where the manufacturers are actually held responsible for recycling. And Call to Recycle is effectively doing this in Canada, the United States now. And you've seen the statistics in the early part of the presentation. There's really no federal producer responsibility law in the United States. And philosophically, myself personally, I think that it would be better that as a country we'd be maybe better off to have an overall federal system, but more effectively is that as consumers of all battery technology, from the alkalines that we use in our remotes for our TVs to using very large battery systems to support backup power and energy storage, we're all consumers of this material. If the manufacturers only just if I'm not being too political here, but if there was some way of some money being set aside on a purchase and have a pool of cash to be able to pay for it in the future, that may be a better way. It seems to work in Ontario and also some extent in California for e-waste in Ontario, Canada. Maybe this could be a formula approach for battery recycling. But the fact is that with producer responsibility, the manufacturers are on the hook, as well as the distributors. And the question here about free riders, the problem is that not everybody is going to be able to be able to participate. There are always going to be importers of material that may not be a brand name product, such as a Duracell battery or an Energizer or some other name brand product. So they, it could be a offshore product inside a toy, and it has no label on it at all. So these batteries, if they end up in a jurisdiction that actually has a producer responsibility recycling program, the way producer recycling responsibility works is that the market share, usually by manufacturer, takes a portion of that pie and pays for that recycling for that year. So the free riders are the ones that are importing or getting them particularly in a jurisdiction and not paying at all. There are Ontario, for example, Canada, there was 5,500 tons, 11 million pounds of disposed batteries. Now, these are not lead acid batteries. These are probably the primary batteries of Alkaline and others. And the goal was to get up to 25%. What they established was the Ontario Stewardship Program. It's a basically extended producer responsibility program. Collectors and processors are paid from the program to recycle. Other jurisdictions, such as the European Union, have a similar kind of program. By 2012, they were looking for 25%. They're trying it by this year, 45%. Where are we? Oops. Where are we looking at in the future? I want to go back to this first slide, if I may. Apologize for. Go back to our opening slide here with the. Oops. The demand curve. As mentioned earlier, this is where that middle curve here with the purple and blue, that's where our problem is going to be lying. Yes, we're going to have still billions of dollars worth of primary batteries to be worried about, but going forward, the secondary marketplace is going to blow up and growing tremendously. We're looking at roughly $5 or $8 billion worth of sales now, going to close to 20 billion, $19 billion sometime in the early next decade. So there's going to be roughly when the batteries that are sold today in that market will be waste probably in 2020 or 2024. And just to give you a sense of capacity, I apologize for scrolling through all this. Oops. Is that here's the scenario that I drew up, is that the problem is that battery plants, processing plants take years to build. They take a lot of approvals, a lot of capital investment. So to turn on the dime to handle all that volume is going to be a kind of a challenge. Also, the fact is I did a little study, a little kind of back of the envelope study of the energy storage marketplace. And I said, well, what happens if we had a producer responsibility model for 100 megawatts of power that needs to be, of small lithium-ion battery cells that need to be recycled in a particular state? Well, doing the math and doing the sort of, that you would end up with 6 miles of battery waste. In other words, if you put them all in about 20,000 pounds or so of waste batteries in the back of a 53-foot trailer, you put those trailers nose to end all the way along, it would be over 6 miles long. That's the kind of waste we're just looking at, 100 megawatts. Those numbers are kind of raw. They're not, it could be bigger or smaller, but those are kinds of the things I'm thinking about. And every time a manufacturer puts out another kilowatt of power out in the marketplace, they're actually putting another several dollars or many dollars of liability out in the marketplace for recycling in the future. So their forecasts are now, I mean, I'm talking to some people in the marketplace now that are saying, well, we're going to be generating 45 gigawatts of power in battery storage in the next year and a half to 2 years. You just can imagine what that would mean if you put it in the context of what the 100 megawatt sample I used. A lot of this is in the future is going to be not measured in tens of gigawatts, but in hundreds of megawatts, gigawatts. And just to give you a sense, the gigawatt is, what's a gigawatt? A gigawatt is 17 gigawatts is equivalent to about the same energy that is, 2.7 gigawatts is what all the power of Niagara Falls, New York produces, and it powers a good portion of the Northeast United States. 17 gigawatts, if it was all released as energy at once, would be equivalent to roughly the power of Hiroshima. So we've got to make sure that we're able to recycle this product very carefully, be able to bring it into the marketplace, and change it. We really desperately do need to change so we're not burning as much coal and other fossil fuels. But we also have to be responsible in the end to actually make sure that we're able to recover this material, because there's not an unlimited amount of lithium in the market in the world. The planet only has so much, and actually it's a lot less than most people think they are. There's probably 800,000 tons of the stuff that we're able to get access to now. So we need to be able to use this and recycle properly so we can actually have a sustainable lithium-ion and other battery technology to actually support our futures. So Wayne, I'll leave it to you to open the floor for questions.
All right, thanks, John. Great presentation. Okay, so we're now going to field some questions from the audience. Again, if you have a question, please enter them in the GoToWebinar dialog box. And we do have a few questions already, so I'm going to start with them. Give me a moment here.
Wayne, can I interject? Is there a way I can see these as text on the screen, or not?
Fortunately not, so sorry. This is going back to your first couple slides. I think you might have covered it, but just to go over the definitions, the primary battery is, for example, a lead acid car battery would be primary battery, and secondary would be, or could be, an automotive lead acid battery that's rechargeable. Is that correct? Actually,
it's maybe to explain that is that primary is used once. Basically, you equate the word primary to use once and use it once only. I mean, once and throw it away. And secondary is reusable. So the categories of batteries that are primary are typically like alkaline batteries and lithium primary, non-rechargeable batteries. So a car battery is the opposite. It's actually a secondary classes. It's termed in the industry used as secondary. I don't like using primary and secondary because they're confusing. It's easier to understand them as being rechargeable and reusable many times, or only used, you can't recharge it basically. So a primary battery is you can't recharge it, you use it up and then you throw it away. A secondary battery is you can recharge it many times until the chemistry is no longer able to support any more charge. Does that help to answer the question? So a lead acid battery for a car would be a secondary battery.
Because that keeps, every time you start and run it, it does technically recharge over time.
Yeah, but in your car, what's happening is that you have your engines actually recharging the battery. So you only need the battery to turn on to turn over the car with a starter, and then once the alternator on the car starts to feed the power back into the battery and charge it back up to its safe level. So that's why it's recharging all the time.
Except when it goes bad, when in the middle of winter, correct?
Well, that's because you've drained it too much, or if it's gotten too cold, and that's again just a different type of chemistry and battery technology. There's only certain limitations of what batteries can do.
Okay. All right, this gentleman works in a city in New England that's in the midst of replacing their parking meters. The old meters have shrink-wrapped packs of 2D-sized lithium batteries with wires attached to them. There could be thousands of these packs, and they've been told it's not worth recycle. They're not bothering with them, and having them professionally disposed of is not economic. What should municipalities do when facing these issues, environmental versus economical?
Well, make sure that they're lithium. This is where the confusion happens quite often. Is you must understand if they're purely lithium, primary, you use once and throw away, and don't throw away. And by the way, don't throw them away. Or lithium-ion. Lithium-ion, if it's lithium-ion, it may be a less expensive recycling. If it's lithium primary, then or non-rechargeable, it would be more expensive. The mission here is that you've got to recycle it. Lithium batteries and lithium-ion batteries pack a wallop of power, and you don't want those to go into first of all, you can't throw them away. They're just too toxic. You can't put them in you can't put them in the trash. So you actually have to find a budget to actually recycle them and be able to alleviate the problem. If you have thousands of these things, it could be, the fortunate thing about lithium technology, it's light. So most of the stuff is, for example, I could fill the truck with lead acid with maybe 10 to 15 truck skids of material and max out the weight of a truck at 45,000 pounds cargo weight. You could put many thousands of batteries inside a 53-foot trailer, and it'd only have about maybe 18 or 18 to 20,000. So you have a trade-off. You fortunately picked a lightweight metal.
Okay, how do you determine which lithium battery has cobalt in it?
MSDS is a short form. It really boils down to is that in order to, and for the previous questionnaire, I mean, I'd be happy to, if somebody can send me the details of the MSDS on those batteries, I can determine if those lithium batteries are in their cost for them. So I'd be happy to do that for any listener. Determine the cobalt is the MSDS. Basically, there's two things we can do. Is we do this quite often for customers and suppliers. Is that we look at the MSDS. We share that with a couple of our major processors. They can assess, because each processor has a different capability. They can assess a value associated, and in the case that there's some enough volume, we actually will send a sample and get a proper assay on it. So that's basically the process. It's not like you can tell by the look on the side of it doesn't say 20%. It's not like a milk carton or a food item on the shelf in the grocery store that shows you the number of grams, unfortunately.
Okay, here's a numbers question. How many lead smelters are there in the United States? And follow up with that, how about processors for rechargeable batteries?
There are, well, I just did this exercise with somebody this morning. There are probably, in Canada, the United States, there's probably roughly, I'm going to just say roughly 10 companies. There may be maybe 13 to 15 sites across the North America, Canada, United States. I'm excluding Mexico. There are some processors in Mexico. Mexico has also taken a fair bit of lead acid weight in the recent years. I'm sorry, I've sort of lost train of my thought there. Is that sufficient, Wayne, to answer that question?
Yeah.
Or?
Yeah, the question was how many lead smelters and how many processors for rechargeable batteries?
Oh, rechargeable.
Yeah.
Right now, I'm seeing, from my knowledge, about maybe 5 or 6 companies that I deal with now that are able to handle rechargeable batteries of different flavors. So like the NiCads, the Lithium-Ions, etc.
Okay, here's a similar question for the alkaline batteries. You mentioned, I believe, 2 in North America, 1 in Canada, 1 in the United States. Where's the one in the U.S.?
One's in Michigan.
Michigan.
There's a not to. I mentioned those 2 because I know that they have a process to extract the chemicals for fertilizer. There are 2 others, one in Georgia and one in Ohio. Actually, the Ohio one is, you may have seen an Energizer ad maybe about 6 months ago where they said that, that 4% of their batteries actually come from old batteries. It's the Ohio processor that's doing that work.
Okay. Is it feasible or cost effective to recover residual electricity from batteries as part of the recycling or processing?
Good question. You'd be surprised. I don't know. There would be a way to hook them up. The problem is that the battery state. When a battery processor gets them, they have no real knowledge of the history of that particular battery, and then also they got enormous volumes of it. So to hook one up each individually to actually test it and make sure it's safe before they actually do something with it would be an extra cost. From personal experience selling the second life batteries that we do for solar applications, for sure, I've seen some mark and spark and it's not fun. So there is definitely some issues to be able to store. We are able to use those ones. They're not every one by any means. There are a very select few that can do that. But we actually have a certification process to, and we do see and know the power of those batteries for the Second Life program we have.
You talked about the use of the alkaline batteries for agricultural use. Could you briefly review that process? This is a totally new concept to this attendee. Sure.
What happens is that the companies I mentioned, what they'll do is they'll bring in they would sort the batteries. The first thing I always do is make sure there's no commingling. That's one of the biggest dangers, as I highlighted before. Making sure there's no lithium-ion energizer stuck in the pile. What they do is then they sort them, make sure that they are in a state to be processed in the battery breaker. The battery breaker actually grinds them up. They do the one I've seen in Ontario, Canada, actually sniffs and tries to extract any mercury. There is still a little bit of trace amounts still sneaking into the system from outside, maybe from outside the country. The processor in Ontario, Canada, actually processes a lot of U.S. and Canadian material. And what next is that they once they get the powder, they'll end up with the zinc, carbon, and the steel, and they get separated by by mechanical means. The powder that's left over is then treated and is chemically separated. Now that could be done at that location, or it could be moved on to another full-blown chemical processing plant, which actually would take that as raw material and then separate the potassium hydroxide out, and also maybe the manganese. And then those chemicals in turn are then added to fertilizers and through a very complex, probably complex chemistry, and then that product is then sold onto to the agriculture industry.
Okay, thank you. How long until the majority of manufactured batteries are lithium-ion?
You're seeing it now. We're seeing in the high energy marketplace, 60 to 70% starting to hit the high energy marketplace, that secondary use high energy market. But there's always going to be a place for lead acids and the others. There, for example, lithium-ion technology. There's this. Just to give you a quick example, there are certain business way electricity is sometimes charged for commercial customers is called peak demand. So what happens is if you happen to use a lot of electricity at one time in 1 month, your bill shoots up enormously. You know, even though you just use it for a millisecond, you may end up your bill being from $400 to $1,000 or $3,000. So what lead acid battery, lithium-ion batteries are used for, they can produce a lot of power very shortly, but the lead acids could be there to help smooth out the power requirements in the future. So they're differences. So you always will have a mixture of batteries. One won't be supreme. It just isn't going to happen.
This might not be. I'm sorry. Do you have a demand graph showing volume, weight, instead of alongside dollar values?
That's pretty hard to do because that one was a very high-end market. Things that could break it down into, there are studies that do that. They're very expensive. But the problem is that you can see that the difference is that you have a lead acid battery that weighs, you know, like in that picture of forklifts I have in front right now, it's maybe 2,000 pounds, or, you know, versus a lithium-ion battery that weighs 20 pounds. It's very hard to break that down and actually get some market share. I'm assuming that some of the maybe the state of Vermont and others will have some more details of that kind of market information for the small portable stuff, rechargeables and non-rechargeable product.
Okay. You might have touched on this a bit. What kind of laws or regulations or programs would be helpful to the industry?
Well, first of all, I think that there has to be laws. I think that there has to be an overall. This is just personal. This is my personal opinion. Personally, I think there is a need to find a way to finance the negative value batteries. If there's no intrinsic value, market value of the product, there should be some type of legislation that would help have us all pay into or find a way to finance and properly process this material. I think the regulatory environments, as I deal with them on a day-to-day basis, stuff around and this domestically is fine. It's a matter of fact is that you have to make sure that people are doing the right thing and actually sorting the product properly. And I think from a federal perspective, it would be great if there was an overall federal legislation that helped understand the paying for and processing the material. Currently, the called Recycle group has had to go to state to state to state to state, and it's the same history that they're battling as has happened in the e-waste industry, where we've got 25 different states that have e-waste laws and all have sort of slightly different variations of the same rule, and some don't. So it's hodgepodge and no clear one solution. The European Union has strived for a overall multi-state regulations, and they have, you know, and that was in my presentation.
Okay, thank you. Please describe how a recycling program should prepare lithium batteries for shipment for recycling.
Okay. Again, make sure that we discern between lithium and lithium-ion. Lithium-ion and lithium batteries are, if they're like the small cells, let's see if I can find the tied around picture. Anyways, basically there's like the small D cells batteries. They are, you know, they need to be taped. Essentially, that's the bottom line. Is you got to make sure that there's no chance of dangerous evolution of heat, short circuit and dangerous evolution of heat. And unfortunately, many of truckers had a flaming trailer behind them. You know, because something happened. Actually, I was inspecting a load and found out that a battery actually had been wire had been cut and it was short-circuiting. It was going to be 11,000 pounds going to California. I'm so glad I found that thing. So you have to make sure that I had to solve the problem by taping it properly and separating the leads. The thing is, you got to tape them, make sure that they're insulated, make sure they're packed. Now, just the battery themselves packed in a box is not sufficient. Certain size of batteries actually have to be, put in approval, UN approved hazmat class packaging in some certain circumstances. Damaged batteries can never be shipped without proper hazmat packaging, and that gets expensive quick because you have a special treatment. It's like you have to put in different containers amongst different types of packaging materials so that it has no chance of actually leaking or exploding or burning, and it has to run by go by ground only. So.
Okay. Switching gears a little bit here, does the amount of CRT glass ready to be processed at the New Life facility and its eventual availability of lead to the market change the long-term value of lead and sustainability of lead battery recycling in the future?
Well, I'd love to say that we would make so much. I have to be somewhat cautious here, but basically the story is that the lead that comes from the back, there's effectively 2 pounds of lead coming out of every old CRT TV. That's about 15 inches. But in the context of 2.5 million tons that's produced in the United States every year, we're a small player, a very small player. But eventually, over time, the reason being is that the New Life furnace can handle, it's designed to handle not many million, hundreds, thousands of tons per week. It's designed to handle about 10 metric tons of glass a day. So we're producing a small amount comparatively to the larger secondary lead smelters. I don't think we're going to shake the core of the lead industry, but we are shipping the material for battery manufacturing through a third party.
Okay, are there any efforts out there being made to regulate the look, the identification of batteries by type?
Unfortunately, no, which would make my life a lot simpler and everybody else's life a lot simpler. It does help a lot. I just had a customer or supplier send me a picture of a battery a week ago, and I saw the bright purple Tadran battery, and I knew exactly what it was. It does help. Certain manufacturers have done that, and it's great, but there's no one sort of, this one's blue, this one's green, this one's pink. It says it doesn't indicate anything about what's inside that case.
Now here's a question on availability of like drop-off programs. I assume they vary from state to state, city to city. So maybe if you a model program out there for like a citizen drop-off or a municipal drop-off.
Sure. I mean, there's well, Call to Recycle is a national program. It operates in all 50 states. It's meant to you go to a local drugstore and they only take rechargeables. They don't take alkalines. They won't take lithium primary or non-rechargeable batteries, but they will take. And the only caveat on that is Vermont. Vermont law just came into play earlier this year, and they are covering only in Vermont the alkaline batteries. So you can find it's basically a little box that sits in the front door of a Home Depot or whatever, and you just drop off your batteries and that's it. There's more formal programs that are available for companies that have small quantities. Excuse me. Some municipalities may actually have this as a collection point at their transfer stations. None that I've had any personal experience with, but I know that they're probably seeing some of the stuff, and they probably need some help to get it properly recycled.
Here's back to regulation and legislation. What's your opinion on the outlook of primary battery legislation in the United States? Do you think there will be more laws like Vermont's coming online?
There's a well, Connecticut's tried, and they've tried to pass a law two times, and I think they basically are going to restudy it again. It's there is interest in other parts of the country. I think Texas is another one. It's going to be evolutionary, not wish this was all sort of one standard everywhere. So there, it's a process where for the I call them portable or smaller rechargeables or non-rechargeable batteries. That market. There's a NatBat. I'm a member of an organization called NatBat out of Chicago, and there's a major in Ann Arbor on November 30th. We're actually convening to try to solve the high energy battery marketplace, which we're all going to be facing. So, hope that answers the question.
Okay. A lot of similar questions on the packaging.
Sure, go ahead.
Well, you pretty much cover it. Can you restate what the market shift was that likely led to the public to believe that throwing batteries away was a safe disposal option? Was it the removal of mercury additives?
Yeah, it was mostly the mercury additives were the ones that were legislated back 15 plus years ago. And that was a federal law, thank goodness. But that was sort of the shift. I mean, and that's a perception, and that's actually it's working against people in certain jurisdictions, such as in Ontario or and over in even in Europe. It's I've been able to throw these batteries. I mean, on my desk I've got a whole bunch of Alkaline sitting here forever. We're all guilty of it. There was a drive in Ontario. Was it Ontario? It was a drive in Ontario just recently that they recovered about 20,000 kilos, which is about 60,000 pounds, 40,000 pounds of batteries. And this just was stuff that was sitting in a small smattering of small cities, and all the stuff that was stuffed in people's junk drawers. So.
Here's some conversation about a bill being introduced in Texas, but they're not confident it will pass. But another one saying we'll be working on it. They have certain people authoring it that they might have some luck there.
Right. It has to be. It's the. I say to my friends at NatBat, I mean, we're going to save ourselves from ourselves by using renewable energy storage and solar panels from greenhouse gas emissions and stuff. But we're going to bury ourselves in it if we're not careful.
Right. Okay. Well, we're just about out of time now. That was a really good question and answer session there. Really good questions, everybody. So we're going to wrap it up. And again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thanks again for joining us, and thank you, John, for taking the time out to make this presentation. We hope you'll.
You're most welcome.
Yep, we'll hope you'll join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. And again, thanks for attending, and we'll see you next time.